Thanks, Scott. What we're going to do is follow up what Scott's comments were going into the break, where some DOTs are really heavily invested in 2D, some are thinking about going in 2D. Talk about where DOT in North Carolina is, which is they're on the path. It's not that it's not been done, but they're well engaged and moving forward. So I'm just going to give a little bit of background, and Matt's going to talk about where DOT is going, or as we were just joking, I'll give the facts and he's going to present on some fiction. So what makes us unique? North Carolina was the first state to fly LiDAR statewide. That really changed the way a lot of the work was done. This was in 2000 and 2004, heavily funded by DOT, if not completely funded in the first phase. It changed because that's when GIS came to be. Then North Carolina got really LiDAR happy. This was a couple of points per 10 square meters. Just a few years ago, they started back and started reflying the state again. And 60% of the state's been flown where they have 2 points per square meter LiDAR. And then the 40% of the state, which is the west, they've actually flown and are producing products at 8 points per square meter. And they're just now starting in partnership with DOT to actually classify that data to 30 points per square meter, and have plans to go back and fly the original 60% of the eastern half of the state and have those same two products, 8 points per square meter and 30 points per square meter everywhere. Now, what that means is that fundamentally changes a couple of things. One, most importantly, the floodplain mapping program in the state is thinking about not doing survey anymore. They think that the LiDAR, for the most part, for the models they're doing, represents the channel and down into the channel well enough. And they've got presentations on that that show that. We're unique in the fact that you look we've got mountains in the west and the coast at the east, so we've got a lot of models in the 1D world that sit on dead red in the mountains. They're sitting right on critical depth. So it's probably not the right water surface elevation, but the models were produced for FEMA, and they don't like you to do subcritical. You've got a lot of the urbanizations in the middle part of the state, so the very complex culverts, very long culverts and things like that. And then down east, it's very heavily ditched and man-modified and exceptionally flat, maybe not as flat as some parts of Kansas, but the wind blows is where the water goes is the joke we use. So there's a couple of different applications for 2D that really make a lot of sense across those. And with the LiDAR, it provides us a really good base. Additionally, another important point is North Carolina has the second most state-maintained roads in the nation behind Texas. There's about 90,000 miles. Is that right, Matt? 80,000. And I tried to show an image so that you can see there's very little that's not covered by road in the state, and that's just for scale. And part of the reason is a lot of the subdivisions in the state actually become state-maintained. This is just north of Charlotte. All that pink and all that red and all that green is state-maintained roads. Another good thing that the state has is, just like most of you guys, they've got an inventory of their bridges, but in addition to that, they're well into collecting their asset inventory. They just started, I guess this month, they've gone and collected all their primary roads, but they're working on the secondary roads now, and have actually collected assets, large assets on the secondaries prior, and they're now collecting 4 feet and under pipes. And that's several 100,000 culvert pipes that they expect to have in the database. So that's a really good piece of data to push into your models that you don't have to go and collect in the field. They're attributing those photos and some field data when they do that. Another piece is the partnership that DOT has with the floodplain mapping program. Jerry covered that pretty well the other day. And if you weren't in there, this is a FEMA compliance MOA. Based on some unique things in North Carolina, they have a letter of map revision delegation and mapping delegation. Jerry, what was the number? It's approaching 2,000 projects that have been pushed back and forth, 1,700. The floodplain mapping program essentially reviews every TIP project, every small pipe project to make sure that there's an increase or not an increase in terms of the FEMA floodplain, and they sign off saying that DOT is in compliance. And what makes that unique is that there is a model from the floodplain mapping program for 30,000 miles of stream in the state, and they're all detailed study for practical purposes. There's no swag, there's no A zones in the state, and so that's a starting point for the DOT work. Now, there's some efficiencies and cost savings, but it also means those are 1D because the state floodplain mapping program is just now starting itself to move towards a 2D world. So moving to 2D, DOT is faced with how do they keep FEMA compliance when there's an existing 1D model, and how do they move to 2D without ending up having to do two models for two different purposes. So it's one of the quandaries that has to be thought through. And so that's the background. Just DOT has been doing 2D modeling since it's a coastal state. Certainly have done plenty of 2D models down at the coast for the bridges, obviously a concern for scour and storm effects. Been doing it in Riverine more recently. The principal levee project there is a recovery effort from the Hurricane Matthew that happened just 2 years ago. It's leading some of the efforts to try to model what needs to be done to the levee and what the impacts from flooding are done by the levee. I believe Moffitt, Jeff's in the back there, Moffitt and Nichols doing that work for DOT. Greenville, I'll actually cover that one, and then there's some forward-thinking stuff, and we presented a little bit on that the other day on what was done with a level 3 wave analysis with AdCert for coastal. So this is a smash up of a couple different projects just as examples. The Sunset Bridge project was modeled with RMA. I believe all three of these were modeled with RMA, Moffitt and Nichol and Ocean Engineering, or the engineers involved here. But Sunset Bridge, the original bridge, was built by a non-engineer developer who just needed to get people over to the island and survive for years and years and years. It was like 2 feet out of the water. So the main concern was the Corps had estimated scour velocities over 15 feet per second. So that was a real design constraint. The RMA helped them do a better job of determining the scour velocities would be a lot lower. At US 70, they were putting a bridge on. There was some other bridges nearby. There was a concern about redirection of waves and maybe making the flooding condition a little worse. So they had actually modeled two different bridges in that. It's combined to make sure that the impacts were reasonable. And then Oregon Inlet, we mentioned the other day. Most of you probably know about Oregon Inlet. The big point there is the reason why you model it in 2D is the scour depths can approach 70 to 80 feet deep. So it's critical. It's the only lifeline to a large part of the Outer Banks. This one's a good example. This is a project where the city was doing a project at the same time, supposedly. DOT was adding some drainage to existing drainage areas by the way they were putting in their pipes. It was going to be pushing more flow into an undersized system. The city was supposed to be upsizing. At the same time, they did not. So a 2D model was done. I think this was SWIM, is that right? Done by Kimley Horn. And the point was to try to measure, could things be done with the sequencing, perhaps some creative things on the upper end to avoid causing temporary increases while the city still had a 2-foot pipe downstream of something like a 6 or 8 foot pipe that was going in. And those are just the results. Long story short is DOT saw that there were some things they could do with smaller events, but since this is down east North Carolina, large events, there's really not a whole lot you could do except wait for the flooding to go down. So, and then there's the wave 3. I clicked an extra button. We mentioned that the other day. This was a large AdCert model done by Max Shepard and others, where historical storms were taken and attacked the bridges in multiple directions just to see what the water surface elevation, the wave action, the scour potential through velocity would be for all of the bridges at the coast. There was also some physical modeling. I'm going to speed up for time. It's all represented in a GIS database and a PDF report. They actually did resisting moments on a number of the bridges to see which ones were at risk of uplifting and things like that. But it was all based on very large-scale AdCert 2D model. And at this point, we put it. That slide there is DOT's putting it out on so it can be pushed out through the web. We presented on that on the other day. If you've got questions, I'm around. But the main point is it's that large-scale AdCert model. So at this point, I'll transition to Matt to go from what the background was to what it means for where DOT's going from here. So.
Thanks, Ken. Thank you, Ken. I wanted to just take a quick moment to thank the steering committee and planning coordination committee and sponsors, and a special thanks to Ohio University for putting this on. So Jeff's still out there, thanks, and really appreciate that. On behalf of NCDOT, we really thank you for your efforts. We know it's a big task. As Ken identified, North Carolina has a history of 2D modeling. in our coastal bridges, and we've begun to use it on the inland applications as well. So I want to get into that a little bit today. We still need to realize, however, the value of 2D in design and operations of our transportation infrastructure. Ken touched on this a little bit, but North Carolina's construction budget last year was about $2.3 billion. Our operations budget is about $1.3 billion, and that supports all the 15,000 bridges and culverts that go over our waterways. And so there's a lot more areas of our system that we need to be looking at. So in addition, North Carolina is the 9th fastest growing state, one of the fastest growing in the nation, with a current population of 10.3 million, going to 12 million by 2035. With this growth, continued urbanization will occur and will lead to more challenging hydraulic conditions. Bottom line is that DOT needs to expand their toolbox, and so better deliver hydraulic solutions in the future, and 2D is one of these. So we're really looking about how we can use 2D. So the next question is, where do we go from here? What is our path forward? How is 2D innovation achieved at NCDOT? To answer these questions, I'd like to share with you how NCDOT is embracing 2D modeling innovation through partnership with the EDC4 change. Scott's mentioned this, the collaborative hydraulics advancing the next generation of engineering. Hopefully I got that right. And we're also partnering with our private engineering firms, like Ken was up here. We're expanding our project application, and we're also looking at some university initiatives. So, and then I'll finally conclude with our next steps and goals. Now, I said that DOT is embracing 2D innovation. That is not totally true. There's a resistance to change. I want to talk about that a little bit. Some of the questions we've received include, why would you want to use 2D when 1D is what NC floodplain mapping accepts? Ken mentioned that. Do you want us to run two models? We have lost 60% of our staff, and the department has increased project delivery by 50%, and you're asking us to adopt and learn something new? The mesh is too consuming to set up when compared to 1D cross-sections. Besides, I only have 2 years until I retire. How are we going to map the floodway? And what happens when the 2D model shows a rise on a structure and the 1D does not? So I don't know how many of you have heard those type of arguments of 2D. I'm getting some nods, so that's good. So the truth is, innovation must be seen or accepted as a significant improvement. So a few years back, Tom Harmon, who's the director of Everyday Counts program at Federal Highways, gave a presentation on innovation while visiting North Carolina. And he provided some really good guidance on how to manage innovation. He gave 10 keys of deploying innovation and the 7 habits of an innovator. However, Tom made 2 points that were really helpful to me. The first was that there's an evolution of a new process or a network that is good to keep in mind. And so it starts out with a new idea, right? Then it builds, and there's awareness of that new idea. And then that goes on to an involvement, maybe some training, maybe getting in some participation, some additional training. And then finally, it comes to ownership, right? And the key is ownership. If our staff owns the process, then we finally have accepted and the real change can begin. So a lot of my job is to see if we can get DOT to ownership, both in the private consulting as well as in DOT itself, and also the universities. The second point that Tom made was that change is always occurring and sometimes very rapidly. Now, when I revisited this slide, I wondered if there was a backstory with Scott and Tom on the slide, since it's very compelling. But the main points that were made were resist change and die, accept change and survive, or lead change and thrive. So, anyway, so as DOT works towards ownership of 2D, we realize that 2D innovation is a significant improvement in several areas. In general, 2D allows, we've talked about a lot at the conference, but it allows for fewer modeling assumptions and less user judgment. It does provide enhanced communication with stakeholders and engaging graphics. And I can't tell you how important that is for us when we engage with our representatives at the Corps and the DENR, and just working through that process of what are we doing to the impact of streams and things. And then 2D is more accurate representation of complex conditions, and we've talked about that as well this week. So is 2D every situation, good in every situation? No, but we should have this tool in our toolbox and take ownership of it, and definitely the answer is yes. So where is DOT going with owning the change? So back in early 2017, we initiated our involvement with EDC4, and as a part of that process, we put together an implementation plan that included 7 items. To date, we've completed 3 of those, and we're actively pursuing the remaining 4. And we should have a decent completion by the end of the year. So of the completed tasks, the most significant to date has been hosting the 2-dimensional hydraulic modeling of rivers at highway encroachments twice in North Carolina. We did it last November, and we did it again in January of this year. And we trained over 60 individuals from state, federal, and private engineering firms. So just trying to get that base going in North Carolina. With the final time left in my presentation, I'm going to just step through where we are on the remaining 4 that are up there. So partnership, it's extremely important. We've got external partners. We've got 3 levels of state up there, NC State and emergency management. We have the federal with Federal Highways, U.S. Army Corps of Engineers. Also USGS is a part of that partnership. And then finally, our industry partners. We have, over 8 partners, and we're continuing to build that core group of consultants that can help us move to the future. In addition, we're doing some pretty significant projects. With these projects, we'll develop strong working relationships with our private engineering partners, build ownership, and develop the scope of work and design standards to facilitate projects in the future. This one here is in Raleigh. It's on I-440 US 70. It's an interchange improvement. There's $227 million in construction costs. It will require roadway improvements within the floodway. There's significant commercial assets. There's $330 million worth of commercial in and around the floodway and floodplain. Crabtree Creek is about 121 square mile urban drainage area with 90-degree bends, constricted channel. So we're putting a team together where we're going to be looking at 1D, 2D, HEC-RAS, and SRH-2D. We're going to do 1D with 2D informed for NFIP compliance, and then we're going to go into 2D comparison. So the main point, though, is this is a very highly visible project, and the value of the commercial infrastructure, and most importantly, protecting the people that will frequent this area in the future. So we just think, I've had some folks say, why do you want to do 2D here? You're just going to get yourself in trouble. And that might happen, but I don't know, from a liability standpoint, I don't know if DOT has any other choice. So, and it's definitely a technology we can use. So today we're finishing up to date, we were finishing up the LiDAR scan of the parking deck underneath there, and that's going to be merged with the existing LiDAR data and the physical structure surveys to complete the digital surface model and for mesh development. And the total reach is about 2 miles. The project team will be meeting the end of this month to talk about moving forward with the modeling. Second project is out west in Asheville. This is the I26 improvements, I-240. So there's a significant amount of work going on that I-26 corridor. I was talking to Randolph at South Carolina, and they're doing a lot of work down there as well. It's about 30 miles of widening and new location. It's about $1 billion in construction costs. There's causeways and bridges affecting the French Broad River and Hominy Creek. The big issue here is endangered species. We have a high level of interaction with the Corps, U.S. Fish and Wildlife Service, DWR, and USGS. And you got the Appalachian elk toe, which is actually in the river. And then we have gray bat. And you said, well, why is the gray bat a big issue for water? Well, we're talking about this endangered species, and they feed along that river, so there's a lot of discussion of how we're affecting the riffles and the pools and where the insects and their food source are. And so the agencies want to know, when we build those causeways, what's going to happen to the river. So it's an important part of the 2D modeling there. So we'll be doing, again, 1D, 2D HEC-RAS and SRH-2D on certain reaches of the river, primarily where we're going to be putting these large causeways in. They'll neck down the river more than 50%. And so there's also the river users. This river is highly trafficked on tubing operations, and that's kind of shown in that bottom picture there. So they really want to know how we're going to affect the hydraulics on that. So 2D will give us that graphical ability to do that. So we'll be using that to help with that. And again, I was, if any of you went to the icebreaker, I had an opportunity to talk with Devin from UGA, and I guess they're working on a project there, so hopefully we can partner on that as we move forward with that encroachment of the causeways into the river. So some interesting things going on there. Finally, on a smaller scale, we're partnering with NC State Biological and Ag Engineering. They have a Class BAE 582 Risk and Failure Assessment of Stream Restoration. So we're going to try to introduce, I'm working with the professor there to introduce SRH 2D scour analysis and continue working with them. And then finally, what are our goals, our next steps? Well, we got 4 areas that we're really interested in. It takes us to design, operations, research and training, and partnership. So in design, we really want to get to that scope of work for the 2D, get some guidance on design guidance, and then continue our work with review and checking of 2D models. Operations, scour investigations, I mentioned the 10,000 bridges, so we have a lot of scour issues at times, and I think 2D can help us to do some analysis there. We also have complex drainage investigations where I think 2D will serve some purposes. Since we own a lot of these roads, we get towns in the mountains that don't have any other resources, and we got to figure out how we're going to move that river through that stream better. So research and training, we're also submitting a research project with it currently in our state research program, evaluating scour and countermeasures on 2 bridges in the coast, and then some in the coastal plain, and the Piedmont, and then the mountains. And then again, I hope we can participate in the next segment of change. So finally, the partnerships, I think that's probably the biggest part we're going to focus on, floodplain mapping, how are we going to deal with the floodway. Again, the university system, federal highways, and professional engineering firms. So I guess remembering the words of Ton Harmon, lead change and thrive. So we'll try to do that better in North Carolina. So with that, I'll conclude. So,
all right, thanks Matt. Ken, any questions for Matt or Ken?
What prompted the decision to include the HEC-RAS 2D in that project evaluation?
So floodplain mapping uses HEC-RAS 2D. And
they allow 2D HEC-RAS?
Yeah, so they use it. And it's part of our partnership, so we're just trying to understand better. There's about 8 bridges in that one project that go pressure flow, so really interested to see what kind of results we get from that.
So this is a broader question then. Is that national, the acceptance of 2D HEC-RAS, or is that just North Carolina?
Ken, you want to answer that better?
It's for FEMA. They accepted it. Floodway issues there, and Scott covered that the other day. The mapping program in North Carolina is moving to it. They're using 2D for certain applications, and they certainly accept the methods CSG uses until they get back to FEMA compliance. So it's a little complicated. They're not ready to move. They can't use SR2H. They can't use it for FEMA studies now. They're committed to the HEC-RAS, so that's part of the reason for the
Thank you.
Oh, and just a sec. Any other questions? Can't get away that fast, Matt. Nobody?
All right, there's my contact information if anybody needs it.
Okay,
So,
all right, great. Thanks, Matt.